All right, today we're tackling a really fascinating financial puzzle, one that actually impacts things like your electricity bill and the entire global energy market.
I mean, really think about that for a second. Most things we value, gold, oil, whatever, their price is partly based on the fact that you can buy them, you can hold on to them, and then sell them later. But what if you couldn't? What if the second something was made, it had to be used, or poof, it's just gone forever?
Exactly. The power that's lighting up your screen right now, you can't just stick that in a box and save it for later. It is a constant, real-time flow. And this whole use it or lose it thing makes pricing it incredibly, incredibly difficult. And that's the puzzle we're going to unpack today. So here's how we're going to do it. First, we'll look at the core problem with these unstorable goods. Then, we'll see how you can build a really solid formal foundation to solve it. After that, we'll uncover this kind of brilliant connection to interest rates. Then we'll check out its real-world applications, and finally, we'll talk about the true power of this way of thinking. Okay, so let's get right to the heart of it. Why is pricing, say, a stream of natural gas or a megawatt of electricity, so completely different from pricing a bar of gold? Well, the experts have a name for this stuff. They call it a flow commodity. And it's mostly energy, things that are always in motion and have to be consumed the instant they're produced. Now, this isn't just some quirky little detail. It literally changes everything about how you model them financially.
This really lays out the difference perfectly, doesn't it? With stuff you can store, you can build up an inventory, you can wait for a better price. But with flow commodities, nope. There is no waiting. Supply and demand have to be perfectly matched, second by second.
And here's where it gets crazy. That real-time balancing act creates these huge price swings, what the market calls volatility. Think about it. A heat wave hits, everybody cranks up their AC at the same time, and bam, electricity prices can go through the roof. Any normal financial model that just assumes you can store the stuff, it completely falls apart. So if all your old financial tools are basically broken for this problem, what do? You've got to find some solid ground, right? You need a completely new way to build a model that can actually handle all that chaos. This is the million-dollar question for economists and financial engineers. How in the world do you bring some kind of order to this mess? How do you create something rigorous and dependable when the thing you're pricing is anything but? The answer, it turns out, is actually pretty elegant. Instead of trying to model the chaos itself, you take a step back. You start with principles that are so basic, so fundamental, that you just can't argue with them. Things like the idea that there's no such thing as free, risk-free money. In logic and math, we call these truths axioms. And that is the core of the strategy. An axiomatic approach is all about building a system from the ground up, starting with just a handful of these self-evident truths. It ensures that everything you build on top of that foundation is logical, it's consistent, and it's super rigorous. If that sounds a little abstract, just think back to high school geometry class. You start with a few basic axioms, right? Like the shortest distance between 2 points is a straight line. And from just those few rules, you can prove all sorts of incredibly complex things. Well, this is the exact same idea, just applied to the world of finance. Okay, so we've got our foundation. Now let's see how this leads to the real breakthrough. This is the aha moment where we connect our big, messy problem to a powerful solution that's been hiding in plain sight. Let's try an analogy. Imagine our challenge, pricing a flow commodity, is like being asked to build a bridge over a wild, unpredictable river that's always having flash floods. It's a really dangerous and unique engineering problem. But what if you already had the blueprint for a standard, incredibly reliable bridge? One that's been tested and proven for centuries. Well, in finance, that blueprint is something called interest rate theory. It's this deeply developed mathematical toolkit for pricing the flow of money over time. It's solid. It works. And this quote from the source material just says it all. The genius of this whole axiomatic approach isn't about inventing a brand new type of bridge from scratch. No, the strategy is to use those fundamental axioms to prove that you can take the existing, powerful blueprint of interest rate theory and adapt it to solve your new chaotic problem. So how does that work? Well, first, you use your axioms to identify the universal principles at play, sort of the financial versions of stress and load and flow. Then you confirm that your master blueprint, interest rate theory, can actually handle these principles. And once you've made that connection, you can rigorously apply all of its proven mathematical tools to your problem. And just like that, you've built your bridge. Now, this all sounds great in theory, but what does it actually mean in the real world? This is where we get to see the real payoff of all that deep, foundational work. The bottom line is this. The method brings logic and, most importantly, consistency to a market that's notoriously difficult. It gives everyone a shared, formal foundation for pricing really complex financial contracts that are based on these super volatile energy commodities. And we're talking about very specific financial tools that get traded all the time. For instance, caps and floors. Those are basically insurance contracts that protect buyers and sellers from wild price swings. Things like those, and even more complex bets, can now all be priced with some real mathematical rigor. So to wrap things up, let's just zoom out for a second, because the importance of this idea goes way beyond just one little corner of the energy market. What we've looked at today is really a perfect example of a much bigger trend happening in modern economics. It's this huge shift toward using these formal, logically sound systems built from the ground up on axioms, to get a reliable handle on messy, complex, real-world problems. And believe me, this isn't some obscure academic idea. The research behind this explainer actually identifies this specific application as one of about 100 core axiomatic concepts that are actively shaping modern economics and social sciences. It's a really big deal. And that kind of leaves us with a final thought to chew on. We've seen how starting with simple, undeniable truths can help us build a framework to understand and even price financial chaos. So the real question is, what other incredibly complex systems out there, from social networks to climate models, could we understand a whole lot better by applying the power of axioms? Thanks for joining me.